Assalamu alaikum everyone. I hope everyone is well. So in this video I'm going to focus on the topic of prime factors, HCF and LCM, which are very important topics for O-level students, specifically for O-level students and also for critical thinkers who focus on mathematics, logic, etc. So I'm going to focus on these topics in this video and the subsequent next videos and hopefully you'll like and enjoy it. So let's jump straight in with the calculator intro. So if I go to this platform, save my exams, and go to the first topic of maths topic questions for Edexcel, number system, and the first subtopic, which is, or the third subtopic, which is prime factors, HCF and LCM. If I open this in a new tab, address the first two, address the third subtopic in the next couple of videos, which is prime factors, HCF or highest common factor, and LCM. So what are HCF and LCM? So HCF and LCM are, or highest common factor is the highest common factor between numbers and the lowest one between more than one numbers. Okay, and lowest common multiple is the lowest common multiple between multiple numbers. So you can just Google the concept HCF and LCM. You'll get clear explanations of what HCF and LCM are. I'll focus on problem solving. So I'll focus on the medium category and the first sub problem, which is very simple. So the first problem deals with, let's read the problem, which is buses to Acton leave a bus station every 24 minutes. Buses to Barton leave the same bus station every 20 minutes. So buses to Acton leave every 24 minutes and buses to Barton leave every 20 minutes. So a bus to Acton and the bus to Barton both leave at 9 a.m. So when will a bus to Acton and a bus to Barton leave the next best bus station at the same time? So if I go to my notepad and use my pen tool, so one bus station leaves every 24 minutes. Buses of one place, which is Acton, leave every 24 minutes. Buses of another place, which is Barton, leaves every 20 minutes. So if I do a lowest common multiple of 24 and 20, what is the lowest common multiple of 24 and 20? Let's use 4. So 4 6 are 24. So 4 multiplied by 6 is 24 and 4 multiplied by 5 is 20. So if I do it, use 2 3s are 6 and 5 cannot be divided by 2, so 5 remains the same. So if I multiply 4, 2 and 3 and 5, we get what? We get 4 2s are 8, 8 3s are 24 and 24 5s are 120. So 120 is the lowest common multiple between the numbers which are 24 and 20. This is the lowest common multiple. There is no lower multiple of 24 and 20 other than 120. So 120 is the lowest common multiple. That means 120 minutes is what is required minimum for the buses of two places to meet at the same time. Or when will a bus to Acton and a bus to Barton next leave the bus station at the same time? So in order to figure out the same time, you have to add 120 minutes to 9 a.m. So they will what is 120 minutes? 120 minutes is 2 hours. So they'll meet next is 9 plus 2 hours, which is 11 a.m. So they'll meet when the bus to Acton and the bus to Barton next leave at 11 a.m. This is the solution to this problem. Now we are going to focus on problem number 2 from the medium level of prime factors, HCF and LCM. So problem number 2 says Rita is going to make some cheeseburgers for a party. She buys some packets of cheese and slices for some boxes of burgers. There are 20 cheese slices in each packet, 12 burgers in each box. So Rita buys exactly the same number of cheese slices and burgers. So the first query is, how many packets of cheese slices and how many boxes of burger does she buy? And Rita wants to put one cheese slice and one burger into each bread roll. So she wants to use all the cheese slices and burgers. So the second query is, how many bread rolls does Rita need? So in order to figure this problem, let me go to my notepad or the OneNote and use my pen tool. So firstly I have to read it again. So there are 20 cheese slices. This is the information. There are 20 cheese slices in each packet. So there are 20 cheese slices in each packet and there are 12 burgers in each box. And another important information is Rita buys exactly the same number of cheese slices and burgers. So I have to figure out how many packets of cheese slices and how many boxes of burgers. So if I do a lowest common multiple of 20 and 12, so let's say I have 2. So 2 is 10 and 6, and then if I do 2 again, it's 5 and 3. So if I multiply 2 multiplied by 2 multiplied by 5 and multiplied by 3, we get what? 2 2s are 4, 4 5s are 20, 23s are 60. So this is the lowest common multiple. So Rita needs 60 cheese slices and 60 burgers. Cheese slices and burgers. So how many packets? So the question for the first query is, how many packets of cheese slices and how many boxes of burgers does she buy? So each packet has 20 cheese slices. So if Rita requires 60 cheese slices, so if I divide 60 by 20, which is 3, so Rita needs 3 packets of, or 3 packets of cheese slices. And if I divide 60 by 12, Rita requires 5 box of burgers. So these two 3 packets of cheese slices and 5 boxes of burgers is the answer to the first query. So if I look at the second query, Rita wants to put 1 cheese slice and 1 burger into each bread roll. So she wants to use all the cheese slices and all the burgers. This is the important information. She wants to use all the cheese slices and all the burgers. So how many bread rolls does Rita need? So how many bread rolls? Now Rita has 60 cheese slices and 60 burgers. One from the 60 cheese slices and 1 from the burgers is required into a bread roll. Okay, so how many bread rolls is required? From if you take 1 from each of 60 cheese slices and burgers, how many bread rolls is required? 60. This is the bread rolls. This is the bread rolls required for Rita. So if I go to the problem number 4 of prime factors HCF and LCM, so the problem 4 has 2 parts, 4a and 4b. So if I first look at 4a, what does it say? It says express the number 180 as a product of its prime factors. So you have to express the number 180 as a product of its prime factors. So if I use my pen tool, so let's say the number 180, or just okay, so the number is 180. So you have to express this number as a product of its prime factors. So if I do divide 180 by 2, we have 90. Then if I divide 90 by 2, I have 45. Now 45 cannot be divided by 2, so it should be divided by 3. So if I divide by 3, I have 15. I have to divide 15 by 3 again. Then I have 5. So 5 cannot be divided by 2 or 3. So what can 180 be expressed as? 180 can be expressed as 2 multiplied by 2, 2 multiplied by 2, multiplied by 3, multiplied by 3, and multiplied by 5. So if I 2 multiplied by 2 is 4, 4 3 is a 12, 12 3 is a 36, 36 5 is a 180. Now if you look at the numbers 2, 3 and 5, all of them are actually prime numbers, because 2, 3, 5, all of them can be divided by only the number itself, which is 2, 3 and 5, or 1 and no other number. So all of these are prime numbers. So this is actually the representation of the number 180 as a product. This is the representation of as a product of its prime factors. Now if I go to the problem number 4b, so Martin thinks of two numbers. He says the highest common factor of my two numbers is 6 and the lowest common multiple of my two numbers is a multiple of 15. So write down two possible numbers that Martin is thinking of. So Martin is thinking of two numbers. So the highest common factor, or the HCF, of the two numbers is what? Is 6. And the lowest common multiple of the two numbers is a multiple of 15. So multiple of 15 can be like 15, 30, 45, ... right? It can be any of the multiple of 15. So from the properties of LCM and HCF, we can write the multiplication of LCM and HCF of two numbers. Let's say we have two numbers. So the multiplication of the LCM and HCF of these two numbers is actually the product of the two numbers. The product of the two numbers. So this is a formula of LCM and HCF of two numbers. So we know the HCF, which is 6. So 6 multiplied by an LCM is a multiple of 15. Okay, so we can write LCM for now. So LCM multiplied by 6 is what? Let's say that those two numbers are represented as 6x multiplied by 15y, where x and y are two integers. X and y are two integers. So 6x and 15y are the two numbers. Now if I use use the values of LCM, so LCM is going to be 15 or 30 or 45, etc. So if I use two values of LCM, let's start with 15. So if I use LCM as 15, then 15 multiplied by 6 is going to be what? 6x multiplied by 15y. So from this equation we can clearly see that x is 1 and y is 1. Then if x is 1 and y is 1, then this equation has left hand side and right hand side equal. So for LCM, if I use the value 15, we get x and y 1. So if we use the LCM value, let's say 30. So 30 multiplied by 6 is what? 30 multiplied by 6 is, can be represented as 6x multiplied by 15y, where in this equation x can be represented as 1 and y can be represented as 2. So if x is 1 and y is 2, both sides are equal. Okay, 6 multiplied by 15 into 2, which is 30. So both sides are equal. So for LCM values 15 and 30, we get, for LCM values 15 and 30, we get x1 y1 and x1 y2. So if x is 1 and y is 1, what are the two values? 6, x is 1 and y is 1. So 6 and 15. So if LCM is, if we take the LCM as 15, which is a multiple of 15, then the two possible values are 6 and 15. And if we take the LCM as 30, which is in this case, we get the value, if x is 1 and y is 2, then 6 and 30 are the two numbers. So 6 and 30. So if LCM is 30, then we get 6 and 30 as the two possible numbers. If x is 15, we get 6 and 15 as the two possible numbers. Now if I look at problem number 5, it says you have to find the highest common factor or HCF of the numbers 72 and 90. So if I go to my notepad and use my pen tool, the numbers 72 and 90, you have to find the highest common factor or the HCF of 72 and 90. So if I divide 72 and 90, both 72 and 90 by 2, we get what? 36 and 45. Okay, so 36 is divided by 2, but 45 can be divided by 2. So but both can be divided by 3. So if I use 3, if you divide 36 by 3, you get 12. And if you divide 45 by 3, you get 15. And both 12 and 15 can be divided by 3 again. So 3 4s are 12 and 3 5s are 15. So if we multiply these three factors, then we get the highest common factor. So the highest common factor would be the highest common. If we multiplied all of these, then we'd get the lowest common multiple. But if we multiplied only the factors used in both the numbers, then I'll get the highest common factor. So the highest common factor of the numbers 72 and 90 is 2 multiplied by 3 multiplied by 3. So 2 3s are 6 and 6 3s are 18. So the highest common factor of the numbers 72 and 90 is 18. I hope you get an understanding of how I approach to solving these problems regarding prime factors, HCF and LCM, or the highest common factor and lowest common multiple, and how I use my methodology to solve these problems, and hopefully it helps the students to figure out their own methodology of solving these type of problems. In the next couple of videos, I'll be going through a few more videos regarding these topics at some different types of problems. So stay tuned for that. So take care.